Hello, I welcome you all in this presentation related with the subject fundamentals of surface engineering, and we have talked about the two big categories of the wear, that is adhesive wear and abrasive wear. In this presentation we will be talking about the erosive wear, which is also commonly observed in the cement industries, hydropower plants, and wherever the free moving particles are interacting with the mechanical components. So, the topic is erosive wear. The mechanism by which material loss in this mode of wear takes place is the erosion, and this is caused by the two types of the situations. One is when the water or fluid droplets moving at a high speed impact with the surface of the component being considered, or hard particle impact or impingement of the hard particle on the surface of the workpiece takes place. So, basically it is the liquid drops of the liquid and the hard solid particles, their impingement or impact with the surface of the workpiece causes the removal of the material. Now, if we see schematically how does it happen, then like say this is the particle and this is the surface of the workpiece which is being subjected to the erosive wear. So, particles will have some mass and it will be moving with some velocity, and based on this we can find the kinetic energy associated with the particle like half mv square. So, whenever a high velocity particle moving at a certain speed impacts with the surface of the workpiece, so it can impact at a high angle, it can impact at a low angle like this. So, in these three cases, say angle of impact is close to like say 80 to 90. In this case impact of angle like 45 to 50, or say in this case it is 20 to 30. So, these are the three angles at which this particle can impact, or it can impact at other angles also, but it can lead to the different ways of the material removal from the functional surface which is being considered, and it's the severity of the impact will also change with the angle of the impact. Whenever it impacts, depending upon the kinetic energy associated with the impinging particle or impinging droplet, it will be causing some kind of the damage onto the surface. So, if the particle size is large and velocity is high, it will be causing the greater damage in form of the surface layer deformation, and one depression will be formed, one some kind of pit or the cavity will be formed. But a particle moving with the velocity v, if it impinges at a low angle, then the energy at the time of impingement and its effect will be less as compared to the case when the impingement or impact takes place at a high angle. So, high angle impingement will be causing more damage to the surface as compared to the case of the low angle impingement. However, depending upon the type of the metal, whether it is hard and brittle or it is soft and ductile, the extent of erosion which will be taking place, that can vary significantly. So, it is the type of material of the workpiece that will govern, that will significantly determine the loss of the material from the functional surfaces when impingement at different angles takes place, even with the particle of the given mass and the given velocity. So, if we see if the mass is more for a given velocity, then the impact, the kinetic energy will be more, and accordingly the effect of impact will be more, and accordingly it will have the greater depth of the pit and greater size of the pit which will be formed, as compared to the case when the mass is less or the velocity is less. So, kinetic energy associated with the particle is less. So, it means if we have the higher kinetic energy of the particle associated with, so increase in kinetic energy in general increases the erosive or erosion of the material from the functional surfaces. So, this is one aspect as far as the erosion is concerned. Now, as far as the different factors that affect the erosion is, so in this case, apart from the indentation and surface layer plastic deformation, which will be governed by the hardness, yield strength of the material. The other factors that determine the material loss by the erosion is also the ductility, toughness, fatigue resistance, and work hardening tendency. So, these are the important properties which will be determining the extent of the indentation or depth of indentation which will be formed, and how easily or with what difficulty material will be removed by the scratching action, especially when the impact or impingement is taking place at the low angle. So, depending upon the material properties of the workpiece material, the indentation and the surface layer deformation will be taking place, and or the extent up to which deformation will be taking place. If the material is extremely hard and brittle, material is having very high yield strength, then instead of the surface layer deformation, the cracking tendency will be more, and that will further start promoting the loss of material by the erosion. So, if we see what are the mechanisms which are playing an important role in governing the removal of the material from the functional surfaces. Say if the particle which is having the sharp edges like this impinging with the surface of workpiece at a low angle like this, so it will be causing the ploughing, and sometimes sharp edges causes the shearing to remove the material by cutting action. So, low angle impingement causes the ploughing and removal of the material by cutting action through the shearing. On the other hand, if the impingement of this kind of particle is taking place at a high angle, then so this will be the more phenomena of the soft and ductile metals. On the other hand, if this kind of the workpiece metal is subjected to the impingement at a high angle, then sidewise flow will be taking place. All the material will be displaced like this in the sidewise. So, this kind of the extensive flow of the metal sidewise, here it will be forming a pit where sidewise flow. So, actually there is no removal of the material, but material flows sidewise. A wedge is formed as per the shape of the particle which is impinging. But if the continuous deformation of such kind of the material takes place, then it will get work hardened and eventually it will be removed. But the removal of the material is less if the soft and ductile workpiece material is subjected to the high angle impingement, means erosion by the particles which are impinging at a high angle. So, this is the case when the sidewise, primarily sidewise flow takes place, and subsequently continued action of the particles, impinging particles, material will get work hardened, then it will also be experiencing the fatigue action due to the continuous impingement of the particles, and then eventually when it loses its work hardening capacity, then cracks will develop and the particle will be removed. But the removal of the material in this case is not at that high rate as compared to the case when the soft and ductile material is subjected to the impingement by the erosive particles at a low angle, and material will be removed by the cutting action through the shearing. So, if we see the soft and ductile materials, it is the fatigue resistance, the ductility which will be important, and the work hardening behavior which will be important to look into the way by which material is being removed from the functional surfaces. On the other hand, if we take an example of the hard and brittle material, in case of the hard and brittle material like this, so impingement of the sharp particles having the sharp edges and corners, if the impingement it is taking place at a low angle, since the particle is the substrate is hard and brittle, so it will not allow the indentation to happen easily, and that is why the abrasion and scratching will be very less. So, less scratching in this case due to the limited indentation, and therefore, wear rate is also less when the impingement is taking place at a low angle, while if the same particle is impinging at a high angle, then it will be the high impact will be will have the tendency to cause fine cracks here and there. Since the material is hard and brittle, it will not show much tendency for the plastic deformation, and therefore, formation of such micro cracks will lead to the removal of the material once the coalescence of these cracks take place. So, in case of the brittle materials, the much higher wear rate is caused by the particles impinging at a high angle, and through the micro cracks and brittle fractures the material loss takes place. So, it is about the shearing, plowing, fatigue in case of the soft and ductile material, micro cracks, micro fractures are responsible for hard and brittle materials, which will be causing the more wear from the material. So, less or the low wear, low erosive wear for low angle impingement as compared to the high angle impingement in case of the hard and brittle material. So, angle of impingement and the workpiece material properties, these are the two crucial parameters which govern the loss of material from the functional surfaces by erosion. Another important aspect here is the factors which govern the erosive wear. So, factors affecting the erosion. So, factors affecting the erosion includes like angle of impingement, angle of impingement of the particle. The second one is the particle size. Then particle size and the shape. The third is about the substrate material properties. Okay, and so these are the three important parameters which will be considered here when we will see that what are the factors that affect the erosive wear. So, as I have said, if we take one particle which is impinging at a high angle, low angle and further low angle. So, impact extent severity of impact is less when the impingement takes place at low angle as compared to that at high angle. So, if we consider the extent of the indentation which will be formed in case of the soft and ductile material, that will be deeper, somewhat shallower and further shallower in case of the low angle impingement, because the extent of the effect of the impact on the low angle impingement is less under the identical conditions of the mass and velocity of the particle. So, the depth of penetration is less in case of the low angle impingement as compared to the case which will be observed in case of the high angle impingement, and this is what we can relate it with the way by which materials behave under the different conditions. In case of the soft and ductile materials, if we see, in this case, although the depth of indentation is less, but material is subjected to the more cutting action by shearing, and therefore, loss of material in case of the low impingement is more by cutting action through the shearing and the plowing. On the other hand, when the impingement in case of soft and ductile materials, when it takes place, mostly the plowing takes place, which does not lead to the much of the material loss from the functional surfaces. So, if we see the effect of the angle of impingement for soft and ductile material, if we keep on increasing the angle of impingement from 10, 20, 30, 40, 50, 60, 70 up to say 90, this is angle of impingement which is increasing, and here we simply write the erosive wear, which we can simply determine from the material weight of the material in before the erosion test and weight of the material after the erosion test. So, this difference will give us the erosive wear, and if we divide it by density, then we will be getting the erosive wear volume lost in the erosive wear. So, if we see there is a continuous increase in the erosive wear up to 30 degree, thereafter it starts decreasing continuously like this. So, initially in this case at about 30 degree the removal of the material by shearing action is the maximum. So, it experiences the maximum erosive wear, and before that the severity of the impact is less, that is why the depth of indentation is also less, and at about 30 degree it causes enough depth of indentation and removal of the material by shearing action, while at the higher for further higher angle of the impingement, the more plowing action takes place. Despite of having the greater depth of indentation, we do not get much of the removal of the material from the functional surfaces, and that is why we see that material erosion of the material at the higher angle of impingement in case of the soft and ductile metals, it decreases, ductile and soft metals. So, this is one thing. So, in this case, to deal with this difficulty, it is important, means those metal systems which will be experiencing the erosion due to the impingement of the erosive particles at low angle, it is good to increase their hardness, so that the erosive wear resistance can be enhanced, but this hardness also has to be increased up to a limit, otherwise it will backfire, or it will start increasing the erosion. The plot where angle of impingement in the x axis and erosive wear on the y axis. So, in this case at low angle we know that if the material is hard and brittle, so with the low angle of impingement there is not much depth of penetration, not much scratching, so the wear rate is less. So, like say 10, 30, 50, 70, 90 degree of the angle of impingement. So, limited depth of indentation, so very less wear, and therefore we get the very low wear rate. So, wear rate will keep on increasing as the angle of impingement is increased, and it reaches to the maximum here. So, because in case of the hard and brittle materials, as the angle of the impingement increases, the severity of the impact increases, and since the material is hard and brittle in nature, so it promotes the cracking. So, rather than cracking, increased cracking and their coalescence, increased microfracturing leads to the removal of the material from the functional surfaces, and that is why in case of the hard and brittle materials, increasing angle of the impingement increases the erosive wear up to the 90 degree, and thereafter it reverses. So, this is one aspect, and the second aspect is about the particle size. So, particle size and shape. Now, the erosion can take place through a very wide range of the particles. It may be in form of the atomic size of like say less than 1 micrometer or 10 micrometer or 50 micrometer. So, they are very large size range. So, whenever the atoms are directed onto the surface like an electron beam or ions, when they are directed onto the surface, we will be seeing that the surface layers of course up to the atomic level, they will be causing the damage to the surface and removing some of the atoms. So, removal of the material in form of at the atomic level takes place when the atoms are directed onto the surface. On the other hand, when the very small size, the particles of like say 1 to 2 micrometer are directed at a high velocity onto the surface, since the mass the diameter is very less. So, it will have very limited mass, and despite of having high velocity, if the mass is limited, then it will not have much of the kinetic energy, and limited particles impinging on the surface with the limited particle energy will be leading to the very less surface layer damage, surface layer deformation. So, in this case very less surface layer is affected, and therefore depth of indentation is also less and scratching is also less. So, in this case when the atom size is when the particle size is very less due to the limited kinetic energy, the surface layers which are affected by the impingement or impact, that is very less, and therefore removal of the material from the functional surface is also very limited. So, this is what we can see when the particle size is very less, the removal of the material by the erosion is less. So, here we have size of the particles. When the particle size is increased like say the 10 micrometer or 50 micrometer, so when the particle size is very big, having lot of kinetic energy, moving at a very high speed, it impinges with the surface of the workpiece. If the material is soft and ductile, it will be causing huge superplastic flow of the material sidewise. Even these particles may get attached with the surface of workpiece if they are if the surface of the workpiece is made of very soft and very ductile, it can retain the abrasive particles, otherwise it may be causing the plastic flow. Or if the kinetic energy of the impact is too high, it may also cause, apart from the superplastic flow, it may cause the melting of the surface layers. So, with the very high kinetic energy particles, if the surface layer melting is taking place, obviously the some of the molten particles will be removed and remaining molten particles will be resolidifying will be solidifying again onto the surface. So, these are the other mechanisms apart from the the indentation, scratching and micro fracture and micro cracking, the superplastic flow and the melting of the surface layers depending upon the size of the particles, it will be affected. So, in general initially with the increase of the particle size, there is increase of the erosive wear of the material. So, this is what we can see as far as the particle size is concerned. The shape of the particle is the another aspect. like if the surface of the workpiece is subjected to the impingement by the spherical particles, since it has no sharp edges, corners to cause scratching or cutting, then this will be leading to the low erosive wear. So, low erosion is observed in case of the spherical shaped particles which are have the rounded corners, not the very sharp edged and sharp corners. On the other hand, angular particles having very sharp corners, whenever such kind of impingement takes place, it promotes the scratching and the cutting action, and therefore, the material loss in case of the irregular or angular shape particles, these promote the erosion significantly because their sharp edges promotes the scratching and cutting action. Now, another important aspect related with this is the material properties. So, as far as the material properties are concerned, it is not just good to have very high hardness, it is required that their material should have the good combination of the hardness, toughness, work hardening behavior and the fatigue resistance. If a material is having these characteristics, then in general under the normal conditions of the erosion, it will offer very good erosive wear resistance. But since many of these are the contradicting properties, so as per the actual situation, we need to see whether the hardness of the surface has to be increased or we need a very good tough surface. In any case, the increased work hardening behavior will be resisting the erosion of the material, and increased fatigue resistance will also be resisting the erosion of the material. So, say in case of the low angle erosion, we need to have the good hardness, while in case of the high angle impingement, it is required to have the good toughness as well as fatigue resistance, so that the crack nucleation, micro fracturing, micro cracking tendency can be reduced. Increase in hardness will be reducing the depth of indentation, scratching, and thereby low angle impingement will be resisting the removal of the material. So, maybe the surface hardening, carburizing, case hardening or development of the hard surfaces through the thermal spread coatings or weld surfacing can be useful for improving the erosive wear resistance of the material. Now, I will summarize this presentation. In this presentation, I have talked about the general principle of the erosive wear, what are the important mechanisms and factors that govern the erosive wear behavior of the materials. Thank you for your attention.